Today, I want to talk about playing games on the blockchain. This is a computer game I played when I was a kid, and it's called Zor. So that's gaming for me. Now I've been talking about dice and randomness, and so Kier Finlow Bates posted this wonderful video, and you guys should definitely go watch this one as well about commit reveal strategies in cryptography and blockchain, and basically you commit to something ahead of time, and then that keeps people from front running. In a smart contract, you can look at the previous block, but somebody could try to front run and um, fake the previous block. And when we talk about looking at the previous block, what we really mean is looking at the hash of the block and trying to pull some randomness out of it. What I do is I come along after the block is created. And that's not something you can do in a smart contract, but that's something I can do because of the way I look at things after the fact. And it is sort of similar to, and I found a die, right? It is sort of similar to throwing a dice and then looking at it, as opposed to throwing a dice and the process of doing that magically registers the number in the system, right? So what I'm saying is, in this game, everybody's watching you play, and by looking at transactions like this, you can do that commit. Like, for example, what I do here is I say things. What I said here is random 4, 6, 25. Okay, so I want to roll a 4-sided dice, a 6-sided dice, and a 25-sided dice. So you look at the block hash, which nobody can have control over, right? You might be able to fake this guy. You might be able to make your own hash or your own transaction ID, right? You could maybe put different data into here, into the body of the transaction, to make that show up differently. But you're not going to be able to fake the block hash. So what we do is we take that first number or some random number. If you want to, there's many different ways to implement this. Right? That's kind of beyond the scope of what I'm saying here. But like, let's say, so this is 5. So you come out to the 5th point here, or that would be, I guess, 10. You come out to 10. And then that is from your own transaction ID. That's the number you pick. That's your roll of the die, right? And then so I show that down here with just one 16-bit number. You can do 2, 4, 8, 16. With 3, I would say that you get a good roll for 3, 6, 12, and 18. And I've never seen an 18-sided dice. I don't really play Dungeons and Dragons to begin with, so I don't know. But there's your 6-sided dice, right? That's the most popular one. That's what this is, right? So that's how you would get, I would say, a fair 6-sided dice in this system. And again, you've committed over here to what you are throwing, right? So 4, 6, and 25. So I'm going to throw 1, 4, so that's 1, 6, that's 5, and then 25. You could throw like a 100 6-sided dice or something like that, and then you would come up with interesting random. You would have to agree on interesting random ways to kind of pull that data. But I'm saying you can do it from both here and here. Here's the code. So you can write the code in normal JavaScript and put it on IPFS. Then everybody can be looking at the same code. So if in this scenario the dungeon master, let's say, is cheating, tries to cheat, or anybody that's playing tries to cheat, everybody else would see, because their code is because they're all going to that same IPFS address.